Okay, we're back on take two. Oh my goodness, I just recorded me teaching this class and I had my audio off. So let's give it another go. But at least, hey, listen, I'm more rehearsed. I know how long it'll take. It'll take about 35 minutes, and we can just go for it. And so let's begin. And this really cute, beautiful picture is and has served its purpose. So to get started, you will likely have this link. And if you don't, you'll type it in now. And you'll get something that looks like this. Okay? GitHub is think of it like Dropbox for programmers. So here is my introduction. If you'd like to join the Google Classroom I set up, then I can't see because I'm hidden here. So you have to click the code and go to Google Classroom and enter in the code, and then you would be in my class. And there's a quiz. So you can go, after you finish the course, go take a quiz and see how you did. Okay, so you're going to open up this file, which is Module 1, Introduction to Data Types. And we're going to be using Google's Collaboratory tool, which is a free tool. You got to do is have a Google account. Oh, wait. I've got my programmer mug. Thanks, Ariel and Johnny. If you want to see what it says says cute stuff. Yeah. So you can, now that you're taking the course, you now can drink from a mug like this, obviously. And if you want to be real hardcore, now you're Hackerman 101. Put this on if, I don't know, if it's not cold. Okay. So you're going to open up Collab, and here we are. It's going to give you a whole bunch of stuff, right? And you get something that looks like this, okay? And I am going to say, first I'm going to collapse the menu, right? And it's already connected. Thanks, Google. If it's not connected, then you're going to click Connect. Okay. To get started, you're going to open up the data. So Module 1, Introduction to Data Types. So we're going to open up Section 1. We're going to collapse the subsections, right? So the first thing is printing. So if we want to figure out what the computer thinks something is, it'll help if we ask the computer to show us what it thinks it is. So if I said, hey, computer, tell me what the number 9 is, it's going to be like, unless you say, tell me, and then it'll be like 9 or whatever. So you do that by writing print. So x equals 9, and tell me what x is. Whoa. So you're going to run this, and to run this, you're going to press this little go button. And it's going to tell me, boing, it's from outside, and we're going to run it anyways. There you go. X is equal to 9. And if you didn't say that, right, so I'm going to get rid of this. And I'm just going to say x equals 9, nothing. So you have to say, print it. Now the thing is, we're in a notebook, which is not like, it doesn't look like code, see the Hackerman 101, it looks a bit more like the type of notebook you might keep in like, a Google Doc. And the advantage of something like this is it'll display the output of each cell underneath it. So you actually don't need to write the word print, you just do X. That works as well. I would stay away from it only because it gets a little hairy sometimes, but you play around with it. So if you want to print out the type of an object, so what is X? Right, we're going to use Python's type function. So X is an integer. Integer is a number. We'll get to that in a second. Or we can print type. They both work. Okay, before we continue, let's talk about what comments are. So comments are lines that are preceded by a hash. Okay, that tells the compiler, ignore what's here. So it's going to be like, meh. And this is meant for people to read. So I want to tell you, don't change this code. It is this is the code that keeps the airplane engine on. If you touch it, then you'll have tons of issues. You might want to write that in a code. You might want to say, to test it, press enter, right? You can give yourself instructions. So comments can be preceding. You can also put a comment, a trailing comment. So if I run this cell, it'll say, got it, and then it'll ignore what's rest. Okay, that's actually not a great way to write comments, but it's possible. Okay. Before we continue, for advanced users, so if you're not an advanced user or you think feel free to just be like, doesn't matter, I'm going to ignore this. But if you want to get a little more hands-on, roll up your sleeves, let's tackle string formatting. So I don't want to print X and then print type. I want to do all in one line. So this is where you want to use print commands, because if you do that in a notebook, it's not going to show anything. So I can say X equals curly brackets, which means filled in later, And the type is curly brackets, fill it in later. And format, which is going to fill it in. So fill in the first one with X, fill in the second one with type of X. They have to be the right numbers, otherwise it's going to give you an error. And I'm going to get X equals 9, and the type is integer. Okay, and there's an even neater way to write it, but it's a little more complicated. It's called F-string notation for format. Right, so you're going to do an F before the string, and you're going to use the curly brackets that you did above, but you're just going to, instead of leaving them empty, you're going to put in the thing right away. Right? So it's very similar. Instead of writing dot format, I put the F in the front, and there you go. Great. So go ahead and try to write something else. Try to write print, maybe make a new variable, name equals Yaakov, and we'll say print, right? We'll put an F in the beginning. We'll say my name is, and we'll put in name. See how that works. Great. We can even put quotes around it, right? Well, I wouldn't put quotes around it. I'll put an asterisk around it. My name is Yaakov. Awesome. So, without further ado, one thing that I did not say is, so you can run each cell by pressing this Go button. You could also, if you hover over it, it'll tell you, you can also run it by pressing Command Enter or Shift Enter, right? Command Enter, is that right? Yeah. There's a whole bunch of ways you can run these cells if you don't like clicking things. And clicking is bad. Hotkeys are good. Great, so we're done printing. Awesome. Let's begin. The first data type we're going to talk about are numbers, are integers. Integers are whole numbers. X is an integer, 100, right? Y is an integer. Negative 200 is a whole number. It's negative, but it's a whole number. And Z. If you think Z is an integer, right, or not, take a guess, right? Like on a napkin, I'll give you 5, 4, 3, 9. And here we go. X is an integer. Y is an integer. Z, not integer. It's a float. A float, let's go on to section 2. A float is a number with a decimal place. For a person, that doesn't really matter, because we understand 6, 6.5, 6.5, we understand what those are. But a computer, they're going to store the information different ways. And a decimal has a lot more information than a number, because a number is either 1 or 2. A decimal can be 1.5000001, 1.500521. Like, there's so many possibilities. So floats take up more space. Nowadays, we don't really care because we have just such powerful computing. But technically, you would want to use integers where you wouldn't want to use floats unless you needed to. Okay, so let's take a look at some floats. 1.75 is a float. Negative 1.75 is a float. How about 7.0? Well, let's give it a go. And they are all floats. There you go. Great. Making good progress. Let's move on to Booleans. So Boolean, and this is what this name makes my 5th graders crack up because it's interesting, it's funny pronunciation. I believe he's a mathematician who studied logic. But, oh yeah, we'll put another beanie, the programmer beanie. Yeah, so a Boolean is a switch. It's either on or off. So it can be true or false. Each language has their own Boolean notation. In Python, it's written title case. So you'll have capital letter, true, or capital letter, false. And these are both Booleans. Cool. Now, let's make a new letter. Let's make something else. Let's just say Z, and let's just say true, okay? And we're going to print the same thing. We'll say print F notation, Z equals Z, and type okay. Cool. So Z is true and type is a Boolean. What if I do true times true? This is why philosophy majors this is why they rock, because they'll be like, oh, I obviously know the answer. But this is why computers rock, because I don't have to know the answer. The computer will know. Well, actually, you have to teach the computer how to know, so maybe you need both. So true times true is an integer. Whoa, that's weird. So the thing is, when you multiply and divide Booleans, Python converts them into numbers. So true times true will be 1, right? And we'll have to do true times false. It's going to multiply them, it's going to be 0. Right? Can I add them? Probably, and it's probably going to become an integer as well. Okay. What if it's true plus true? Right? So that's really weird. What if I want to say, I'll make a list. Don't worry about this in a second. What if I say, are all of these true? True. How about if I change one of them to false? Are all of these true? False. Right? How about any of them? Are any of them true? Yeah. How about, is 6 greater than 5? It is. How about 6 greater than 10? False. How about zoo equals zoo? Are they equal? They are not. False. Right? How about z in zoo? Z is in zoo. These are all different types of booleans, right? The end result is Z is true. How you got to true or false doesn't matter. You can get the true or false from really complicated algorithm, but booleans are either true or false. They have 1 or 2 values. It's complicated to get a boolean sometimes, but that's not relevant to the computer. Great. So integers, floats are types of numbers. Booleans, true or false. Let's get to strings. Strings are words. They're things strung together. So here is a string x, and it's prototype. X equals prototype. Doesn't matter if I use single or double quotes, right? Do I use double quotes or single quotes? Python's compiler doesn't care. They're both going to be the same. In fact, what if I just type this out? What if I say prototype equals equals? Let's copy this one here. Are they the same? They are. Because Python ignores the quotes. It just looks what's inside them. So keep that in mind when you write your code. It doesn't matter. So I would say choose one and stick to it. So I actually don't have a type that I stick to, so I have guilty, but it's better to be consistent. So choose one and just get in the habit of writing with that consistently. How about a bunch of words? Is this a string as well? Let's test it out. Yes, it's a string. It's just strung together. How about z equals 9? So this is not the number 9. This is the string representation of 9. So this is going to be not an integer. It's going to be a string. I can turn this into an integer by telling Python specifically make this an integer. But until then, it's going to assume that it's a string. Now, this matters because numbers numbers have numerical and string representations, and each operates differently. So if you were bad at math, bear with me. This part might be a little challenging, only because it makes math. It's not math. It looks like math. So 9 times 2 is 18. So if I say z2 equals, and it's going to tell me 18. Okay? And it's an integer, obviously. Now what's 9 times 3? 27, right? But the string 9 times 3 is going to be 9 3 times. It's going to be 999. There you go. Flip the cane and the devil laughs. 999. So it's not 27. It's ABCs. And that makes a little more sense when I say 8 times 2. Right? It's going to be AA. Now, here's the funny part. What if I say, take 9 times 2, which is 18. Right? We already did that. And make that a string. Then do that 2 times. That's going to be 18, 18. And if you want to see how that works, try that out, play around with it. Change some things. See if it comes out to be what you want it to be. Right? 9 times 10. See if this is the thing that you expected. So play around and get comfortable multiplying strings, numbers. And we're done. Cool. So let's get to lists. So we're done with strings, with floats, booleans, and strings. We're up to lists. So a list is shopping list, right? It's a bunch of stuff in order. And just to take a step back, a list is iterable. It means there's stuff inside. So if I ask you, is a box of cereal iterable? It is, because you can open it up and inside is cereal. 1, 2, 3, right? Is a banana iterable? Yeah, because you can peel it and then there's one banana inside of it. How about a grain of rice? Is that iterable? It's not, because it is one thing. I can't open it. I can't iterate on it. I can't zip it open. Is a number iterable? No. Is a Boolean iterable? No. Is a string iterable? Yes, because there's individual characters. Is a list iterable? Absolutely, because it's literally something that I want to open up. So let's do that. So here's a list. List number 1. List number 1 has numbers 1, 2, 3. And I want to figure out how long it is. So I'll say len, which stands for length. And I'm going to print these out. Okay, I'm going to print out in just a moment. List 1 has 1, 2, 3. List 2 has ABC. List 3 has 1, 2, 3, A, B, C, 6. Let's give that a go. Right? That makes sense. 1, 2, 3, 3. This makes sense. A, B, C, 3. And this makes sense as well. 1, 2, 3, A, B, C, 6. Now here's the one that gets a little funny. Why does this only have 2 things inside of it? List number 4. And that's because list number 4 has 2 objects. This is the first object. There's a list inside a list. 1, 2, 3 is the first item. A, B, C is the second item. Cool. So I'll play around with that. See if you add stuff, what happens. And let's talk about using lists. So here's a list of some favorite foods. They're pretty great. There's cake, there's sushi. You choose one. You can add something to it if you like. Right? And we're going to run that cell. And let's say I want to know how many things are inside my list. So I can do length. Get me the length of my favorite foods. So I can type that out. All right, let's just type that out here. Length of fave foods. 9. And what if I add something to it? I'll say tacos. Now there are 10. And what if I want to make this a comment? Back down to 9. Okay, so I'm going to run this cell. There are 9 things. What if I want to say, how many times do people like sushi on my list? So I'll say count sushi. There's 2 sushis. Okay, cool. It's that easy. If you count something that's not on the list, zoo, you'll probably return 0. Yeah, there's no zoos on this list. Okay, so here we go. And that's the same as before, just a little bit nicer formatting. Print in one cell. Now, what if I want to know how many characters are in this thing entirely? So I can do something really cool in Python. I can take all these words and just, well, not just Python, most languages. I can just put them all together. And I do that by using the join function. So join function, I write join, and I put what I want to join inside. It has to be a list. Okay? And then what I'll do is, what am I going to connect them with? So I write it like so. And I'm going to create a new cell so you can see. No, not a text. Code, yeah. So I'll say join fave foods. And I put it all together. What if I want to join them with asterisks? Right? That's cool. And what if I want to join it with a comma? Cool. That's nice. So that's how that's done. So I'll put them all together in a word blob. I'm going to make them no spaces. Okay. I'm going to print the word blob. And there's going to be 1 space because of ice cream, right? How many characters? 51. Booyah. You now know how to use lists. Great. So we're going through iterables. The first iterable data type we learned are string. The second are lists. Let's talk about dictionaries. So I just showed you a bunch of really cool foods, but what if I care whose food it is, right? What if I said, I don't just care about pizza and sushi. I want to know what Sam's favorite food is. What's Lisa's favorite food? So there, a list isn't helpful anymore. Now I need something specific. Lists, they're just a bunch of stuff. Dictionaries are specific. They'll tell me things about a person or things about items. So a dictionary is structured as follows. You write it equals curly brackets. It's not square, it's curly. And I'll assign keys with values. So the keys here are breakfast, lunch, and dinner. There cannot be duplicate keys. I mean, you could try, but it's going to overwrite them. It's only going to keep 1 value per key. And the values are unique. Well, the values don't have to be unique. The keys need to be unique, and each key needs to have a value. So breakfast is pancakes, lunch is pizza, dinner is sushi. Right? Keys and values. And what's my type of fave food? It's a dictionary. I don't need to write it like this. I can write it in 1 line. right? It's a little uglier, but there's certain times where that's relevant. And that's the same thing. Cool. So now you know how a dictionary works. How do you open a dictionary? What if you want to get stuff from inside of it? Okay. So here's some different foods. It's important to spice life up, to have variation in your life. Otherwise, every day looks the same. So we're going to be dynamic, keep you guessing, but breakfast is still going to be pancakes because pancakes are great. Okay. So what if I want to find out what my favorite lunch is? So I'm going to type in fav foods, and I'm going to use square brackets. And I'm going to write in the thing I want to get. So I want to get lunch. And there you go. Google's being really helpful. They're sharing with me what I'm highlighting. So I'm going to get my favorite lunch. I'm going to print it out. My favorite lunch is pizza. So let's try that again. Let's just do that again. Fav foods. Okay, and let's get supper. Salmon. Let's start with lunch. Right? This is the key. I'm typing in the key, and I'm going to get the value. What if I ask for something that doesn't exist? So that's going to be down over here. So let's get rid of this guy. What if I ask for favorite dessert? Well, dessert is not in, right? So this should give me an error, and it does. Let's read what this error says, right? There's a big line, and it gives me error, key error. That's the type of error this is. A key error means the thing you're looking for isn't in the thing that it is, right? Skip to the bottom, key error, dessert. Dessert is not in the thing you're looking for. If you want to know where the error took place, it tells you, right? Here is the Python input. This refers to, I think the Python compiler, but this is the line of code that it had an issue on. So it had the issue, here's line 1, here's line 2. Fav dessert equals fav food dessert, right? This is where the error was, and there's a key error. There's no dessert in favorite foods. Great. What if we add dessert? What if I say favorite foods? I'll add it up here, dessert. I'll say dessert, and I'll say chocolate. Okay. No key error. What if I get rid of chocolate? Key error. Okay, so we don't want key errors. They're bad. So what we're going to do is we're going to avoid the key error using Python's get method. Shouldn't say function. I'll keep the function so it can be same as yours, but it's not a function, it's a method. They're more or less the same. Basically, I'm going to write favfoods dot get, and instead of using square bracket, I'm going to do dot get parentheses. I'm going to use the key. Okay, so my favorite food is nothing. So it doesn't break. It tells me the thing you're looking for isn't there. None. Now, what if I'm like, but if you didn't tell me your favorite food, it's probably cake, because everyone likes cake. Everybody likes cake. Wait. Everybody likes cake. That's Donkey from Shrek. Everybody likes cake. So, what you'll do is you'll write the same way as before, but you put a comma and you'll put in cake. And then your favorite dessert is cake. And you can change it. You can say my favorite food is parfait, even though this is maybe not how you spell it. Or you could say error. Right? So we make it back to cake. Cool. So now you know how to operate through a dictionary. You know, open a dictionary. So we are done data types, and now we're going to use them. So let's just do a quick recap. Integers are whole numbers. Floats, numbers with decimal places. Booleans, true or false. String, ABCs. Lists is it's an array with values. And a dictionary, keys and values, keys and values. Cool. We are now going to iterate through a list. So we talked about iterating, right? Iterable is something you can open up and do stuff to. So let's iterate through a list. Here's a list of some yummy foods. Pizza, banana cake, yum. So how do we access each item in the list? The answer is, whoop, we loop through it. So let's run this cell. If you don't run it, then yummy foods doesn't exist. The computer's gonna be like, what? What's yummy foods? Error. So you have to tell it yummy foods equals this. Then we're gonna go over here. And if you want to add things, you just put a comma and you'll say, Laffy Taffy, gushers. So we'll say for food and yummy foods. Right? And it's gonna create a variable food, and it's gonna say pizza, and then it's gonna update each one. What if I want to change it? I don't like food. Let's say I want to say X for X and yummy foods. Make sure you change it here too. and it's going to operate the same way. Okay. Now, does X still exist? If I print it, yeah, it's the last one. What if I don't want it to exist? What if I want to delete it? So I'll say delete X, and then I'll print X. X does not exist because I deleted it. So you don't really have to worry about that. Just keep in mind when you create a variable, it stays until you tell Python, get rid of it. So cool. For X and yummy food, print it. Now, what if I wanted to figure out how many letters are in each word of each food? So I'll say for food and yummy foods, N equals the length of the food. The length is how many characters. Then I'm going to print the food has this many letters. Pizza has 5 letters. Banana cake has 11. So P-I-Z-Z-A. Yeah. So we see very clearly that banana cake has the most letters. It's obviously the best because it's the biggest. And then I could say, all right, I only eat foods with letter A because my name's Yaakov. I've got 2 A's. So don't give me none of that none-A business. So you can say, okay, for food and yummy foods, if A is in the food, print it. And if it's not, skip. Right? There you go. And let's just say you want to say else print. Shame on you, food, for not having any A's. Yeah, shame on you, popcorn. We could put like little asterisks before it so we know to be ashamed of it. Shame on you, popcorn. Shame on you, gushers. What? Gushers? No. Okay, so that's how you can, that's where lists are really useful. What if I want to figure out how many letters, how many times the letter A is in each word, in each food? So I can say, for food and yummy foods, N equals food, count the letter A's in the food, and then print it. So pizza has 1 A. Banana cake has 4 A's. Wow, that's really good. It's the best. What if I only want to print things that have more than 1 A? So I could say N equals food count A, and I could say if N greater than 0, print it. So now we only print the ones that have. Cool. So we're done iterating through lists. Let's iterate through dictionaries. So iterating through dictionaries is a little different. And here is a new favorite foods. We're just going to keep updating it because life should be different and have variety. So I'm going to run this all so that favorite foods exists. Okay. So remember, there's 2 parts to dictionaries. There are the keys and the values. Okay. The keys are what you're going to use to reference it. So it's breakfast, lunch, snack, supper, dessert. And the values are the values corresponding to those keys. Pancakes, sushi. Right? Why don't we go ahead and add something to it so we can see if it's there. We're going to say, we'll say, I don't know, tea time. We'll say beverage. We'll say I love ginger beer. The non-alcoholic type, by the way. Really amazing. So I'm going to add it, and I'm going to run here. And now I've got a new key, and I've got a new value. Cool. And so those are my keys, and those are my values. And then I can also operate the items, which are going to be key value pairs. So breakfast pancakes, lunch sushi. Right? So cool. Now remember I said earlier you can't have duplicate keys? Well, what happens if I try? What if I say breakfast is equal to waffles? Okay. There is not going to be a second key for breakfast. This will be just 1 key. The same number of keys. The values are not going to, instead of pancakes, it's going to be overwritten to waffles. Because what happens is the dictionary will write the first thing, then it's going to be like, oh, breakfast, okay, I'm going to write a new pair for breakfast, and that's equal to waffles. It gets rid of the first one. Pancakes, I don't know who that person is. Never heard of them. It's gone. So you want to think about that when you build data structures and how you keep track of things. Let's get rid of waffles because I really like pancakes a lot. Okay. And let's just run the cells again so that we don't have to see the previous ones. Cool. Pancakes are back. So how do you go through this dictionary the same way we went through a list? So you see how we printed all the keys? So I can say for key and keys, right, print. Remember how last time I accessed the value using a key? So you can just do that here, right? So for key and keys, breakfast pancakes. There you go. Pretty easy. There's a neater way to do that because here the keys are really easy to get. But when I access the value from it, I have to go into my dictionary and unpack it. I have to go through however many things. Imagine you're doing a huge data structure with hundreds of thousands of items. It's going to get really slow. So this is where you can. This is where accessing it through a built-in iterable, which is instead of looking it up, you can use the item pairs that are previously. So it's going to break it out into pieces, and you don't have to look it up every single time, right? So I can say for key value in items, print the key and the value. And there has to be a comma there because it has to be get me these two things from this. So it'll say key value, breakfast, pancakes, lunch, sushi. Right? I can say if A in value, then print it. Nice, right? So breakfast, snack, supper, and dessert have A's. There you go. And what if you wanted to overwrite values? What if you want to overwrite values? So you saw earlier I wrote directly into the dictionary, breakfast is waffles, but I can just set it here. So I'm going to just print favorite foods. And pancakes are gone. Remember how I said it's permanent? Be careful. For overwriting values, you don't get it back. But your code will be written, so you can always look at your code. But okay. And what if I wanted to add a new value? I want to add a midnight snack of Gushers. Awesome. So I can just add, instead of going back and rewriting it, then rewriting it, I can just add it to the dictionary here. So I can just say, yeah, just take this new key. I don't know if you've heard of it. And add it. So let me do that. And let's go all the way to the end. Midnight snack is Gushers. Awesome. So we added it to that. Don't worry about deleting values just yet. There is an easy way to do it, but we're not going to focus on that just now. Okay. Now, what if I have a bunch of secret snacks I like? I like dessert for breakfast, dessert for lunch, dessert for snack, right? I don't want to add them one by one. First, it's going to be annoying, but what if I had thousands of values in another dictionary, right? What if I had some code that did this whole fancy thing and I just want to add it all to another dictionary? It's going to be a lot of code. It's going to be a lot of writing to get line by line each one. So there's a very easy way to do it. I take my first dictionary, favorite foods, and I update it with my second dictionary. And I'm just going to run this cell. And there it is. It's all here. So give yourself a go. See how it works. Try to add some things. Maybe popcorn. All right, it's there. Cool. And we are done. So we now know how to, aside from understanding data types, we know how to iterate through lists, iterate through dictionary. You are now done. You now know enough about Python to be dangerous. Just before we finish, let's get hands-on. Let's actually do something. So we're going to make a dictionary of your favorite food. Okay. And the keys are going to be your food. And the values is going to be another dictionary. And in it, we're going to have the calories, the weight, and the price, and if it's healthy or not. So here are, and we're going to do it together, okay? Here's my favorite foods. And these should be your favorite foods. Okay, so you're going to add some things here. Code, we're going to add your favorite foods, okay? Let's say you like pizza. So we're going to search calories and 2 slices of pizza. Great, 570. And how much does it weigh? 214 grams. Okay, price. Let's just say it's $5. Is it healthy? Not the last time I checked. So if I print out favorite food, my favorite foods, I get pizza. So what if I want to find out the information for pizza? There you go. What if I want to find out if it's healthy or not? It's not, right? Let's add another food. So I'm gonna add, I don't know, avocado. Calories in avocado toast. Yeah. Let's go back to avocado. So an avocado, a whole cup of avocados, all right, whatever. An avocado has 234 calories. It is 146 grams. And let's just say it costs $1.50 because you shop at a fancy grocery store. And it is healthy. It is not pizza. It is avocado. Okay, so understand that each dictionary, each item here has a dictionary, and the dictionary has value pairs. Okay, so I'm going to do pizza. How about avocado? Healthy. Nice. Now, what if I wanted to loop through each one? Let's actually add one more thing. Let's just make. We had banana cake earlier. Banana cake. In banana cake. Don't tell me it's 196 calories. That's stupid. 60 grams, that's too small. Let's just say it's twice that. And we'll just say 60, twice that. And since I don't care about math, because I got a computer, it's going to do it for me. Let's say the price is $2.50. Let's say it's not healthy. Okay. So, great. So, I don't want to type in each one by one. So, I could just say for key value in items, print key. And it's going to go through each one. Pizza, avocado, banana cake. Right? If I want to only do the first thing, I'll just say break, which means don't after you do the first thing, stop. Okay, pizza. What's the value going to equal? It's going to equal this dictionary, right? All right. What if we print the type? The type should say dictionary. Yep. So let's go back. So I want to say health H equals value healthy. Cool. So I'll say print H. So we'll say, okay, if H equals true, print key. The only thing that's healthy is an avocado. Oh man, I'm gonna be hungry. Okay, what if I wanted to say, get me the thing that has the cheapest? Like I'm on a budget. So let's get price. So I'm gonna comment this out. Okay. And I'm gonna say P equals value price. Print P. Okay. So now I have each thing with the price. Now, what if I want to find out the cheapest food? So here I'm going to say, it's a little bit of logic here. I'm not going to, yeah, let's just do it. We'll say min P, or let's do it backwards. P min equals start at 0, okay? And we'll do P food equals none, because I don't have anything set. Okay. So, and here we're gonna print P, and we're gonna print P min. Okay. Let's go to this guy. So P min starts off at 0. Right? So I'm gonna say if we'll say equals, let's just say 100. Okay, because we're going to go down. Well, actually, we're going to go the most expensive food. Okay, so P max, okay, equals 0. I want to find the most expensive food. We're just going to change it. Okay, P max. Okay, cool. And there's nothing there. So P max, okay? So we're going to say if P is greater than P max, then print P, right? And they're all going to be greater than P max because everything's greater than 0. So if it's greater than P max, then P max equals P. And now we have the most expensive food, right? And what is that? So we're going to say print K, print key. It's going to be pizza. So we'll say if the price is more expensive than the current price, make the current price the most expensive, and also make the current food the food. And so if I go all the way back and I say the most expensive food is pizza. What if I do it separately then? What if I do it with calories? So I'm going to do it, well, we know that calories is also the most expensive. What if I do it with, oh man, pizza's the biggest for everything. It's biggest for weight, for everything. Well, what if I only want to do this for healthy foods? I'm eating healthy today. So I'll say if value healthy equals true. Okay, now only do it if it's true. Wait, and we gotta move this to the side. There we go. The most expensive healthy food is an avocado. Awesome. So I'm just gonna leave this on the screen. You can read through this and type it on your own. And with that, you're finished. You're done. You now know enough Python to call yourself introduced. So you are, I've dabbled in Python, getting started. That's how you can talk to people now. You could also drink out of a mug that says programmer. But I would caution you to telling the whole world just yet, because maybe they'll start quizzing you and you'd be like, I need to get back to you on that. So that's pretty cool. And I'd say if you are curious to join the class that I've created and do some homework, definitely check out the link from before. So hopefully the audio worked this time, because if it didn't, I'm going to lose my mind. And happy learning. No, I do it up here.